All right, welcome to the next video in our series. Today we are introducing the next challenge we have. It's inspired by a internet series that at least appears to be popular, right around the year 2020 when this is recorded. Who knows if it'll still be popular when you hear it later. But the idea is we're going to ask the question, will it triangle? So Good Mythical Morning, they ask questions like, will it taco or will it piñata? We're going to ask, will it triangle? In this lab, we ask our programmer to write a program which can take in 3 lengths from the user. We ask the user for 3 lengths, and we determine if the 3 numbers that they give us can make a triangle. That's the first part of the question. Then we ask what kind of a triangle is it by length, and what kind of a triangle is it by angle. I know that we're in a programming class. You probably were thinking you wouldn't need to do much math. I promise this is the most math you're going to do all year, the whole term. So let's break these down one at a time. First, I want to recommend. We'll talk about the blocks that you need. There's a description in the PDF that's posted. But let's talk about the math. When we're given 3 lengths, we don't know if the user is going to give us the shortest length first or the longest length last. We're going to have to do a little bit of work to make sure that we know what's the longest length and what are the other 2 lengths. In math, we traditionally say that a triangle has sides A, B, and C, where C is considered the longest side and A and B are the legs. Obviously, if this is an equilateral triangle, the assignments of A, B, and C don't really matter, but that's okay. So the first thing we're going to ask is, after we figured out who's the longest side, there's a pretty simple math equation to check if it's even possible. If the longest side is shorter than the sum of the 2 legs, it can be a triangle. It totally makes sense. But if the longest side is bigger than the 2 legs added together, well, imagine holding those 3 triangle lengths. You'd lay the 2 legs along, they wouldn't reach the full length of the hypotenuse, the longest side, so that doesn't triangle. So after we get the 3 lengths, we determine who's longest, we do a little bit of math. We're going to talk about the blocks that we need to solve this one. This part, not as painful. All right, let's get into what makes it interesting. Oh, okay, well, I guess that's part 3. Part 2, classify by length. We know that a triangle that has all equal sides is called equilateral. We know that if it has 2 same sides and 1 different, it's considered isosceles. And all 3 different sides is going to be scalene. We'll talk about some logic, some blocks that help us approach that. And then here's the one where I'm going to inflict a little bit of math upon you. Forgive me. But we want to know what kind of triangle it is by angle. So we know the famous Pythagorean theorem, a squared plus b squared equals c squared. When that's true, a squared plus b squared equals c squared, then we know we've got a right triangle. What's a little less talked about is if the relationships between a squared plus b squared and c squared are different, we actually know a different kind of triangle that it might be. For example, if a squared plus b squared is bigger than c squared, that means that your legs are a little bit longer, and what that does is it makes the long legs shrinks that longest side, makes it an acute triangle. Conversely, if the longest side, c squared, is bigger, well, think about it, if the long side gets big, that's going to stretch open that right angle, it's going to turn it into an obtuse triangle. Oh my gosh, that's just say triangle. Obtuse triangle. All right, so we have a little bit of math to do. We got to figure out what A, B, and C are, square them, do some addition, and then we can figure out what kind of a triangle we're looking at. The extra credit in this particular case is being able to draw the triangle. That is a pretty excellent extra credit option. It involves trigonometry. You'll want to look up, I think the one you want to use is law of cosines would help you draw that. There's a hint video posted that you can absolutely check out. All right, so the last thing that I'm adding to this video is I'm going to recommend when you're done with your program, try out these test cases, enter these lengths in this order. I've got a couple of ones that won't triangle. I've got one example of a right triangle, 2 obtuse, and 3 acute. Make sure that you've really put your code through the ringer before you turn it in. All right, so let's look at the program and execution. I've got the guys from Good Mythical Morning. And again, I'm going to go ahead and spoil what variables I used. So I stored three variables called first, second, and third. The reason I call them that is because it's the first number I was given, the second number I was given, and the third number I was given. Then the way I did it in my code, and I've seen students do this different ways, so don't feel like you have to go down this route, but I made three more variables called A, B, and C, where I knew that C was the longest and A and B were the other two sides. I think it's useful to, after you're given the three sides, go ahead and sort who's bigger, and that saves you from having to constantly be checking later on if you do it one time, and then you can just refer to these variables later. I also made variables so I could save what kind of triangle I'm looking at. So after I figure out what's its classification by angle, I save that word in this variable. What's its classification by length? I save that in this variable. So let's look at some examples. What is the first length? Perhaps it's 3, 4, 5, and it assigns those correctly. It says it will triangle. It makes a scaling right triangle, and that's correct. If I execute my program again, maybe it's a 2, 2, 5. 2, 2, 5 will not triangle, and then it doesn't bother trying to classify anything because, it can't triangle. How about if I did 9, 10, 1. Oops, I meant to say 11. That definitely won't triangle. Let's try that again. We're going to say 9, whoops, 10, 11. It will triangle should be a scaling acute. Yes, very good. And then let's give one more example. Let's try 50, 50, 50. It should triangle, and it should be an equilateral acute triangle. Very good. All right, so what are the blocks you're going to need to be successful in this lab? Let's head over here. So for starters, we're going to be doing a lot of asking, answering, and then assigning those answers to some variables. So you're definitely going to need those. And then this lab is really all about stretching our skills with operators. I've identified many of the operators that I used and how we can place them in if-else blocks. So let's talk about that. We recall that some of the math that's involved, for example, this right here, we need to be able to say, is C less than A plus B? Well, you could see putting together is C less than A plus B, and then we could slot that inside of an if block, and right away we're actually, that's a chunk of the way done with the code we need to figure out if it'll triangle, right? So we can nest some of these reporters inside other ones. So that's how to approach the logic of part one. In part two, we have to ask the question, are all the sides equal? So to figure that out, I'm going to recommend using and, right? You're going to want to know, is the first side equal to the second side, and is the second side equal to the third side? If that's true, then you're looking at an equilateral triangle. The reason we use and is because and's job is to report back true only if each of the predicates it's holding is also true. If one of them's false, then and does not return true. So the way and works is, if they're both good, then I'm good. If either one's bad, or if they're both bad, I'm bad too. So you need two trues to make a true out of an and. Well, the math with isosceles gets a little bit different because once we've determined, maybe it's possible up here, we're like, look, if A and B are the same and B and C are the same, it's equilateral. All right, once we've proven it's not equilateral, then maybe we're down in this else block, right? So we checked up here, hey, is it an equilateral triangle? No. Well, then the next thing we ought to try is figuring out, is it isosceles or is it scalene? Now, you might be wondering, well, what if I want to check to see if it's scalene first? I'm going to tell you, I think it's actually easier logically to eliminate the possibility that it's equilateral and to eliminate the possibility that it's isosceles, because trying to start by proving scalene, you'd have to say A is different than B, and B is different than C, and A is different than C, and I just think that ends up being logically more complicated. Maybe that makes sense to you and you can go that route, but I think you might be doing it the hard way. All right, so I'm going to check, hey, is it equilateral? If it's not equilateral, then I got to know, is it isosceles or scalene? That's what we're checking right there. So what I want to know is, okay, if we've proven it's not equilateral because we're down here in the else, and I'm going to check, is A equal to B, or is B equal to C, or is A equal to C? And the reason we're using ORs now is the way OR works is I just need one of these to be true to get the whole thing to return true, right? If A is equal to B, but it's not equilateral, we know it's isosceles. If B is equal to C and it's not equilateral, we know it's isosceles. So I actually get to link together a group of these OR statements right here because I have to check the three possibilities, right? There's three possible pairs of triangle signs. You can have A and B, B and C, A and C, and I'm going to check all of those. If that's true, then this middle slot is for isosceles. If it wasn't equilateral and it wasn't isosceles, well, shoot, it's got to be scalene then, right? Okay, so that's how to approach the math of part 2. In part 3, we got to deal with all these squares. Now, we already have talked about the equality operator predicate and the inequality operator predicate. What we haven't talked about yet is how to square things. Thankfully, that's not too painful. You just put whatever your side length is here. It's probably going to be a variable squared. And now I can start asking questions like, is a squared, let's do it, is a squared plus b squared equal to c squared? Now, obviously, I'm missing in these blanks, there should be variables. I'm going to let you fill that in. But is a squared plus b squared equal to c squared? That's how you know it's a right triangle. And if that's not true, then you can check, all right, maybe they're not equal. Maybe one is greater than the other, right? If c squared is greater, then you know you're looking at obtuse. If a squared plus b squared is greater, you know you're looking at acute. All right, so I just want to do, that's an overview of the blocks that'll be useful. As always, try to use broadcast and when I receive to break your code up. It can be a very long chunk of code if you don't start to break it apart into pieces. So remember when I receive and broadcast and wait. I think those are good tools to have. And then the other thing I would say is let's do a little bit of mapping out. In programming, when we want to talk about our plan for coding, we call that pseudocode. It's where we write out our code maybe a little bit informally, so it's not using the fully correct syntax, but it gives an idea of what we're going to do. So here are the steps I would recommend. 1, you're going to ask user for the 3 sides, save those to variables. 2, let's go ahead and sort which variable is the largest and which 2 aren't. That's where I set things up to A, B, and C. 3, determine if it will triangle. And remember, if it doesn't triangle, you don't have to do any of these other parts. And then from here, you can do these in either order. I would say classify by angle, and then classify by length, and then you're good to go. That's my recommendation. All right, thanks for watching.